Hello and what's up? This is the episode 2 of the Arduino beginner series. So, yes, sorry I haven't uploaded Arduino video in a long time. And my previous video, if you know, I have taught you how to write a simple sketch and blink a LED according to your needs. So today is the another episode, and in this episode again I'm gonna keep this simple because I don't want to mess with your brains. So in this video I'm gonna show you how you can use the serial monitor and display important informations and logs into that, because that's one of the basic and main things you need to know before you write some fancy code. So let's get started. And in this video I'm not going to show you using any physical hardware, because I want to give you a tip by using Tinkercad. As you can see, I have opened Tinkercad. You can see the URL over there. It's www.tinkercad.com, and here you can make Arduino circuits and actually do whatever you want, but virtually. And guys, this is not a sponsored video you guys may think of. I just want to give you this tip because here you can use, let me show you how to open it. As you can see, this is the main page. You have to sign in first. I have already signed in, as you can see, and then you have to click on these circuits right here. After you click on the circuits, you can see I already made different kind of circuits there, but just ignore that. You will not find these circuits as your first, but then you have to create a new circuit over here. It may take up some time to set up the CAD. There we go. As you can see, here are your components. You can pick up whatever components you want. You can see this is the basic components. If I select Arduino here, then you will see we have already our blinks circuit ready. So see, there are a couple of different circuits over here, and you can just select all. Then okay, these are starters. No, I want to select components right here. So as you can see, we have ultrasonic sensors also in here. I don't know, maybe, oh okay, these are two different models, so whatever. So you can search over here Arduino. See, I have Arduino Uno i3. Arduino Uno R3. So you just want to drag that in your, okay, the drag doesn't, yeah, there we go. So what you may think, what is the advantage of making circuits here? Rather, you can do some practical by making circuits in your original physical Arduino. So I would say the plus point of making circuits here is, as you are beginners, it might help because you can do whatever you want here as of the original Arduino. But if you make some wrong circuits, or as a beginner you are free to make mistakes, it may damage your original Arduino. But if you use it here, it will not damage anything, because it will just give a warning that let me show you. Maybe let's say you put a lot of voltage to an LED. Okay, now let's grab this LED here. So if you don't know, LED needs a current limitation. If you put enormous amount of voltage in LEDs, it will just blow up. So let me say I'm providing 9 volts to my LED without a resistor. What the heck? Don't have a battery? Okay, there we go. So as you can see, this is the cathode, this is the anode. So I'm gonna connect this negative to the cathode and the positive, okay, let me say a detour, to this anode. Now I have my simple circuit ready. Now you just have to, okay, let me, yeah, there we go, hide that Arduino because we are not using that here. So then start simulation. See, you can see current through the LED is 915 milliamps, while the absolute maximum is 20 milliamps. So in real life, if you make this kind of mistake, then your LED just will blow up. But in here, it just gives that warning. And you can see this little boom symbol right here, or whatever it called, maybe boom symbol or whatever symbol it's called, just zigzag, circular, or whatever you call it, I don't know. So this symbol means we have a warning, and see, it gives that warning. And now we have to put a resistor. If you put a resistor and make the resistor value to 1 kilo ohms is a little bit overkill, but still leave it like that. And I'm gonna delete this, no, delete that, there we go, and put that resistor in here, and then connect that to the battery, and then start the simulation. See, it's absolutely okay. It's not giving that warning, and still I can change this value to some, see, it just started like that, 808 milliamps. So 1 ohms is not the thing we need. We need at least, maybe according to my experience, we need to 20 ohms maybe. There we go. You can see it's still 30 milliamps, which is okay, above that 20 milliamps. So LED will glow, not blow up, but will not like it for a long time. Maybe if you glow it for some 15 minutes to 20 minutes, it will blow up. So this is a pretty amazing background, amazing platform in which you can make your circuits. Let's delete all of these. Okay, so according to my last video, I am again going to make a blink sketch. Okay, so here we put resistor in ground, LED, there we go, LED. The anode will be connected to what, D4, right? I'm just making the same circuit as I made in my previous video, the simple blink sketch. Okay, this is gonna connect to that cathode. Let me give the color as black and red so that it's easy to understand. There we go. So now we have our simple thing ready. Now I can tweak with the code. You can see the code right here. Okay, so let's open the code, and you can see this is block. Okay, so I'm going to text. I'll share one block. So yeah, there you go. So the blink sketch is already written in here, see, but just I have to change it to 4. If you haven't watched my last video, you should watch that, because I have discussed all of these, how the blink works. So okay, don't need these comments because, well, there you go. Now I just have to upload it. You just have to start the simulation basically. It will automatically upload. See, the LED is blinking. Let's try to reduce this a little bit so that the LED glows brighter. There we go. See, now you can see the LED blinking. So now our today's topic is how to use serial monitor. Let me say you have a infrared LED over here, then you will not be able to see the glow of it. Okay, so in that case, serial monitor comes in handy to detect whether the LED is on or off. Let's treat this as a infrared LED now, but anyways, you can see it blinking, but still I'm going to show you how you can write a simple serial monitor code and print the state of this LED in your serial monitor. So 2 changes you have to make in your current code. First thing is, in the setup section, you have to, okay, I have to stop the simulation first to edit the code. There we go. Here you have to write a line called serial.begin. Okay, and then it takes one single argument over here, which is the communication speed. You know, serial monitor actually what it does, take the data from this RX and TX pins to the serial monitor. So basically it needs a communication speed, isn't it? It's basically a communication, so it needs its speed. and we call it baud rate. Okay, so I am providing here 9600. That means this is the communication speed. You can put whatever you need. 9600 is a pretty low speed of communication. You can speed it up by actually using higher speeds like 115200, something like that. But as I have already told you, I'm going to make this video simple, so let's begin with this 9600 baud rate. So then we have to print our LED state. Okay, so as the LED is becoming high, we want to print high. Okay, so there we go, serial dot print ln. Actually, this is the function serial dot print or serial dot print ln. What ln does is break the line, and the next serial print command will be print in the next line. So basically, I am providing it here serial ln. I will also show you how serial print does look like. So as you can see, serial dot print ln, and now we have to print this LED state. So I'm declaring a new variable called LED state. Okay, and now going to close the bracket, and then going to put here LED state. Also want to put LED state in here as high, and again put the same command, copy, paste, and here I'm gonna put LED state as low. There we go. Now my code is uploaded, and you can see the LED blinks like normal as usual. Now we have to open the serial monitor. Now see, it's printing ones and zeros over here. As I've shown in my previous video, as I've told in my previous video, that high means 1 and low means 0, isn't it? That's basically the binary representation. High means high, that means 1 or 5 volts, or low means 0 or 0 volts. So as you can see, as the LED glows, it prints 1 in there. And okay, I'm going to bring it down so that you can see it more clearly. There we go. Holy sh! There we go. Now as you can see, 1 means high, 0 means off. 1 on, 0 off. 1 on, 0 off. Just like that. And you guys may be thinking that the code is dumb, isn't it? It's pretty dumb, as I am selecting high as LED state, as defining a high, and then using that LED state only, and then printing that LED state only, which is actually kind of dumb. But for your understanding, I am doing it like that. As you can see, as I have put high in there, but still it's printing 1 and not high. That is because it always prints the binary representation. Okay, so I'm just printing this LED state in here, and as you can see, I am printing this. Let's say I am removing this print line. Okay, I have to just stop the simulation. So this line, I want to remove this ln. Now let's see what happens. There we go. There we go. Start the simulation, and see, it just prints one after another. As I've already told you, line does the break. If you put ln in there, print ln, then it just breaks the line. 1, then breaks, then 0, then breaks, then 1, then breaks, like that. And as I've not put any line in there, it just prints it like this. There is no one to break the line. So let's again put ln in here. There we go. Start the simulation. Now you will see 1 0, then it will break, then again 1 0, and then it will break. So basically it will print 10 10 each time. 1 means on, 0 means off. 1 off, on, off, like that. Hope this helps, and hope it clears your doubt. Another comment you can give through the serial print. Let me show you. You are just printing a variable and its state, isn't it? Value of the variable with your serial print this time. And now let's say you want to print your name or whatever thing you want. So how to do that? Let's show you. serial.print. Okay, I want to print something like my name and then something like I type it here. Let me say Outta and then something like this and the LED state, which will be 0 and 1 obviously. So I want to print something like this. So what I have to do, serial.print, then the bracket starts, and then the turning point is you have to use double quotation. Okay, there we go, the double quotation. Now we want to put Outta in here. Okay, and then the colon and hyphen over there. So as I have not put a ln in there, then this will not trigger the break line, and the next print statement will be printed just beside of that. That means our LED state will print it like this or this. Now again on the next we have our Outta, then our LED state. Outta, it will be 0 over here because, okay, sorry, it will be high over here because I have pulled it high, as this is high. So as our next one, I just want to copy this, copy, and I'm gonna paste it here, and I'm gonna put it syllabus. So how it will look, so let me show you. Outta, it will print 1 because our LED will be high, and then on the next line, as I am using here print ln, then after 1 it will break, and then it will print syllabus and 0 because our LED state is low there, so it will put 0, and then again it will break. So that's how basically it works. So let's upload the code and start the simulation. See, Outta 1, syllabus 0. Wow. Now hope this solves your problems. I hope I have not messed with your brain so much. If I did, then sorry for that. I tried to keep this video simple as possible. This is also a small video, but maybe you will learn, maybe you learned a lot about the serial begin function and how to use the serial monitor. So that's all for today, I guess. In my next video of this series, I will show you how to use PWM, and as you can see, this LED brightness is constant. Let me zoom in. So see, 1 0 1 0, and as you can see, this LED brightness is constant. I will show you how you can design a code in which you can tweak the brightness of the LED, fading a LED. That will be the topic for my next video. Till then, keep watching Outta Syllabus. If you like this video, hit the thumbs up, thumbs down for the opposite, and if you haven't subscribed yet, then don't forget to subscribe and hit the bell icon below to get notified about my latest uploads. This is Malhari. You are watching Outta Syllabus, and I am signing off.